Hello Year 8, and today we're really going to start focusing on glaciers. So put the title, what is a glacial budget? And today we aim to learn about, we want to know why glaciers are constantly changing in mass. That's how much there is, how much ice there is. Explain glacier mass balance and with ideas of accumulation and ablation zones, and be able to link this to climate changes. So write the title before moving on. Now, to get started, I want to give you an opportunity to think about these questions that are shown at the top here. So pause and just have a little think about these questions. Now, probably the most important thing that we get before moving on is that we understand what a glacier is. So a glacier is essentially a little bit like a river of ice. Okay, so it's ice, a big mass of ice that you can often not see moving at all, but is they do move very slowly. You might have to use like a time lapse. Some of them might move a couple of meters a year. Some of them might move a couple of meters a day. Uh, but they are all very slow moving. However, they are nature's bulldozers, and they just carve their way through landscapes with ease, and create some wonderful and beautiful features. They're also often huge. You can see in the bottom right picture there, you've got somebody in a kayak, and that gives an idea of the scale of some of these glaciers compared to people. Now that guy in the kayak is being a little bit dangerous, because if there was to, what you often get on the end of glaciers is what we call calving, where chunks of ice just fall off into the water below. And that would cause like a small tsunami that could cause him to topple over or be quite dangerous. And so it'd be wise not to get too close to that glacier snout, the end of the glacier. Um, now, and over the next few slides, I'm going to go into explaining some of the key aspects of glaciers, and we're also going to be looking at a video. But I want us to understand this lesson, how glaciers get bigger and how they get smaller. So this map shows where we get glaciers around the world. So the purple areas show where we've got glaciers around the world. Just pause it for a minute and just think, what pattern can you notice? Where do we get glaciers? Think about the pattern. Okay, so hopefully you've spotted two key patterns. The first one is areas of high altitude. That means it's high up. For example, the Alps. So if we look at where the Alps are, most local glaciers, I suppose, the Alps there. You've also got the Himalayas and the Andes are some of the easier ones to spot, but there are other ones such as the Rockies, and in Africa, think of places like Kilimanjaro as well. But that shows where we've got high areas. So where you get really high areas, you get glaciers, and that's because as you go higher up, it gets colder and colder because the air is becoming thinner and thinner, and it makes it makes it much colder. The other pattern is high latitude, so areas of high latitude. So that means close to the poles. For example, along Greenland is very close to the poles, and in Antarctica is close to the pole. Okay, so we get glaciers at high altitude and high latitude. The sort of linking factor is that these are both cold areas. Now, the thing I said earlier is that glaciers are like rivers of ice. However, this can be a bit misleading. They don't form by just being a river that's frozen. That would just be a frozen river. However, glaciers form where you've got piles and piles of snow building up. So this mostly happens through snowfall, but there are other methods such as avalanches falling onto the glacier, and posh words such as sublimation, where moisture comes straight out the air and freezes to the glacier. But the main method is through snowfall. Now, hopefully on the picture on the right, you can see that there's layers. And each of those layers were laid down at each winter. So they go back, you can count down these layers like years in like tree rings, basically. We've looked at this previously before. Now, as that snowflake falls, it traps air. But when snow falls, it's white in colour, and that's because it's 90% air, and there's lots of gaps in between, and it reflects light in all different directions, so it appears white to our eyes. But if that lasts through the next summer, and then snow falls on top of that, then it will begin to get crushed by the weight of snow above it, and so the air is pushed out, and it turns to what we call granular ice. And then once it becomes a year old, it becomes what we call firn ice. Now this happens again and again and again until more and more air is pushed out, and eventually you end up with only about 20% of the ice mass being air, and they're trapped in bubbles. And then eventually it becomes glacial ice, which takes to between about 20 and 40 years. Once it's glacier ice, it's a bit like the ice that we know, but it can change shape. It's under so much pressure that it acts differently. If you put a force on it, it begins to just change shape, almost like a very, very strong plasticine or something like that. That just changes shape. Under extreme weight, it doesn't break or shatter, it just changes shape, and that's a key property which allows it to then flow and these glaciers to move around. So what I want you to do just before you move on is just write 2 short sentences to explain how a glacier gains mass. And so we talked about how you've got snowfall, and how layers and layers of snowfall each year build on top of each other until eventually the air is pushed out and it turns to glacial ice. So you've just looked at how a glacier gains mass through accumulation of snowfall. We're now going to look at ablation, how a glacier loses mass. Okay, and there's 2 key ways. There's melting and there's calving. So melting and calving both cause ablation, so loss of ice. Now you can see on the picture on the top right is a glacier or an ice sheet even that's melting. Now what's dangerous about that is that if you went into it, although it'd be very cold, it would also perhaps maybe just shoot underneath the glacier, and it could and if it's an ice sheet like Greenland, for example, it might go a kilometer deep, because liquid water is actually more dense and heavier than a glacier. So the liquid meltwater always wants to try and get to the bottom of the glacier, where it helps to then make the junction between the ice and the ground underneath slippy and lubricated, so it moves a lot more easily. And then calving is where lumps of ice fall off the end. So especially this tends to happen, especially if the glacier snout, the end of a glacial snout, goes into the sea or into a lake. This is where you get huge chunks of ice just falling off into the lake or the sea, and these create the icebergs. For example, the one that caused Titanic to sink. So that's how glaciers lose mass, through melting and through calving. So now let's look at how the glacial budget works on a model idea of a glacier. So on the picture on the right, you've got a side of a valley or a side of a mountain, and the white bit is showing the glacier flowing down it, moving down it. It will move very, very slowly and constantly. Now, snow will fall on the entire of the glacier most likely during the winter, but during the summer, you're going to get melting. Now, probably the only area of the glacier that you're not going to get melting on is the area highest up at high altitude, because it gets colder there. So snow is most likely to survive all the way through the summer, right at the top of a glacier. And if it survives its way through the summer, then it's going to get snowed on top of, and then that's caused accumulation. It's lasted, and that's going to add mass to that glacier. Lower down the glacier, it's warmer because it's lower down, and you get more melting. So you get the ablation happening, the melting and the calving, which is reducing the amount of mass on the glacier. Now, if you was to go at the end of the summer and start walking up a glacier, you'd have to be careful of doing that. Walking up a glacier, you'd get to a point where you might see a line. You might see a line of thin snow where it's just at the equal amount of where it's melted and where you've got snow that's just about survived. So you see a little snow line. Now that was what we call an equilibrium line. That's where the loss and gain of ice are equal. So the equilibrium line. And it's sometimes referred to as the equilibrium line altitude. So how high that line is. If you had a very cold summer, for example, that equilibrium line would be much further down the glacier, for example, maybe around here. And that would show that the glacier was going to be growing quite a lot because it's got a lot of area where it's gaining mass, so it's going to grow and be really healthy. If you had a really warm summer, like what we're tending to get more nowadays, that equilibrium line would be higher up. The area where snow survives all the way through the summer would be much higher up the glacier because it'd be warmer. Okay, so the equilibrium line or equilibrium line altitude is really important for showing the health of a glacier, and that is often referred to as the ELA. So I've just briefly explained some of the key ideas around glacial budget. However, this is all brand new stuff to you, and I wouldn't be surprised if it was causing a little bit of difficulty at this time. So what I want you to do is to watch the video here. The video will be on your Teams. Your teacher will have posted it. If you can't find it, just mention it to them in the Teams Q&A. But they should have made it available to you. And follow that, watch that. It talks through similar things that I've done, but probably slightly better with images as well. So just make sure you watch that, and then I want you to come back and do these questions. So first of all, I want you to make a copy of the diagram to the right. So make a copy of the diagram to the right and label it with zone of ablation, where it's losing ice lower down the glacier, zone of accumulation, where it's gaining ice, the glacial snout is the end of the glacier, and equilibrium line altitude, where the gain and loss of ice is equal. Then I want you to go on to these secondary questions. So task 1, where do we tend to find glaciers and why? What happens to the accumulations when the accumulation zone is bigger than the zone of ablation? What happens when the zone of ablation is bigger than the zone of accumulation? Quite a complicated one. And number 4, how has the climate change affected the equilibrium line altitude of glaciers around the world? So pause here and do those questions, watch the video and do those questions before moving on. So just check your answers here. So I'm just going to go through them really briefly with you. So where do we tend to find glaciers and why? So we find them at high altitude, so high up, and high latitudes, close to the poles. What links these is that they are both cold areas, if you're high up or if you're really far close towards the poles. What happens if the accumulation zone is bigger than the ablation zone? Well, that means the glacier will get thicker and they advance. When we talk about glaciers getting bigger and expanding where they are, we call that advancing. So they'll get thicker and they would advance. They have more overall mass because they're gaining more ice than they are losing, and the equilibrium line will be lower down the glacier. The kind of opposite is true for number 3. So if the ablation zone is bigger than the accumulation zone, the glacier will be getting thinner and retreating upslope. So that's another word. So they retreat back upslope. Most glaciers around the world are doing that. It will have less overall mass as it will be losing more ice than it gains. The equilibrium line will be higher up the glacier. And then finally, how has climate change affected the equilibrium line altitudes of glaciers around the world? So they're generally getting higher up as warmer temperatures mean more melting and calving. So that's ablation. So it causes the ablation zone to get bigger. There are some, however, very few, that have gone due to increased precipitation, more snowfall as it gets warmer. So let's check our understanding now with just a quick quiz. So put the questions 1 to 10 in your margin and then answer the questions. All the answers are the key terms in the right hand side. So you need to use words from there to answer 1 to 10. Pause here before moving on. So here are the answers. Check the ones that you got right, tick them if you got them right, and correct them if you got them wrong. And then post your score in the Teams Q&A. And then there's a little challenge there. Why have some, but only very few glaciers actually grown as climate change has caused them to get warmer? Can you explain why some glaciers have actually grown? Pop your answer in the Q&A in Teams and see if your teacher will say you're right or not. Okay, well done for finishing today's lesson, and until next time, goodbye. Hopefully we'll be seeing each other very soon.